Hi everyone, welcome back to another video. In today's video we will be talking about KCL and KVL again, and we will use these principles in the circuit here. On the right hand side we are given three resistor values, R1, R2, and R3. So as we can see here, these are already labeled in the circuit, so this is our R1, this is R2, and this is R3. We are also given two voltage sources in the circuit, and we already know their values, where VS1 is 12 volts, VS2 is 4 volts, and we also know the voltage drop across resistor 2 right here. It's given to us, so this is the voltage drop right here. So that is a given. So the first thing that we want to do to be able to solve this circuit, our objective is to find all the currents and voltages that are not listed. So we need to label each node first. So just kind of skimming over the circuit, I already labeled the nodes, so we can just put names for them. So we have our node A, this will be node B, this is node C, and this is node D. And also another thing that we can do to help us analyze the circuit is that we can go ahead and put more currents here. So we can also put a current across our first voltage source, which we can call IS1, and the same principle here for VS2, we can call this IS2. And by putting these currents here, we will be able to find the KCL equations for each node. So let's go ahead and write out our KCL equations here. So for node A, all we need to do is look what currents go into the node and what currents leave the node, because we know that KCL is current in equals current out. So using this equation here, we can see that only one current goes into node A, which is IS1, and only one current leaves node A, which is I1. So what we can do, we can say IS1 is equal to I1. Now for node B, this one's a little bit more complicated because there's more than one current going into the node. So as we can see here, we have I1 going into node B, and we have I3 going into node B also, and we have one current leaving node B, which is I2. So same thing, we just have current in equals current out. So all we have to do now is just say I1 plus I3 is equal to I2. Node C now. This one is a lot more simple than node B. It's just like the first one, where we have IS2 is going into node C and only I3 is leaving node C. So we have IS2 is equal to I3. And our final node is node D, and once again we can see that I2 is the only current going into node D, but there are two currents leaving node D, which is IS1 and IS2. So we can say I2 is equal to IS1 plus IS2. Now that we have all of our KCL equations written out by using these nodes, we can now find our KVL equations. But before we can actually write our KVL equations, we need to identify all the loops of the circuit. So now, let's go ahead and identify our loops. So we have loop 1, we have another loop here, which is loop 2, and we have one loop, which is the outer loop. This is loop 3. So I'll go ahead and copy and paste this circuit down below so we can get a better view of it as we write our KVL equations. And we can put it right here. So just looking at the circuit here, we want to write out our loop 1 equation. So all we gotta do is just follow this loop here. So we'll start at VS1, go to V1, and go down to V2 right here. And we will also be using the first potential voltage potential right here, so we'll be starting at a negative voltage potential, then hit a positive voltage potential for V1, and then a positive voltage potential for V2. So we can say negative VS1 plus V1 plus V2 is equal to 0. And we can rearrange this equation to say V1 plus V2 is equal to VS1. Same principle applies for loop 2. We'll go ahead and start at VS2, so same thing, we're hitting a negative voltage potential first, so we'll say negative VS2 plus V3 plus V2. So this is negative VS2 plus V3 plus V2 is equal to 0. And we can rearrange this also to say V3 plus V2 is equal to VS2. And one more loop equation here, which is loop 3. This will be the outer loop. And we can say negative VS1, because we're hitting the negative potential first, plus V1 minus V3, because we're hitting the negative potential first here, and then plus VS2 is equal to 0. So let me go ahead and write that out. We have negative VS1 plus V1 minus V3 plus VS2 is equal to 0. And we can also rearrange this one to say V1 plus VS2 is equal to V3 plus VS2. Now, what I'm going to go ahead and do is convert each of these voltages using Ohm's law. So instead of saying V1, for example, we will say I1R1. So going over loop 1 again, we can just say I1R1 plus I2 R2 is equal to VS1. Now I'm not converting VS1 to Ohm's law form because it's a voltage source, so I'm just going to leave that the same. And same thing applies for loop 2. We can say I3 R3 plus I2 R2 is equal to VS2. And then our final loop, say I1 R1 plus VS2 is equal to I3 R3 plus VS2. Now that we have all these equations here, we can go ahead and start finding our currents and voltage drops. So the first thing that's pretty evident to me is that we can find the current across resistor 2. And you may be wondering why. Well, I can tell you. So if we use Ohm's law, so that's voltage is equal to current times resistance, and you can rearrange that to say current is equal to voltage divided by resistance. Well, we already know the voltage drop across resistor 2, which is 2.622, and we also know the resistance value of resistor 2, which is 12 ohms. So now let's go ahead and find current 2. So this is V2 over R2, where we have 2.622 volts over 12 ohms. And using your calculator, you get a value of 0.2185 amps. Now, that we did that, we can go ahead and find other values. So we can go ahead and find voltage 1 actually also. And this is coming from our loop equation, the first one that we made, which is V1 plus V2 equals VS1. And since we know the values of V2 and also VS1, we can solve for V1. So V1 plus 2.622 volts is equal to 12 volts. So all we have to do is subtract 12 by 2.622, and that will give us our answer for V1, which is 9.378 volts. Now also we can find V3 using the same method of the loop equations, because we have the loop equation of V3 plus V2 is equal to VS2, and we already know the values of V2 and VS2 respectively. So we can say V3 plus V2 is equal to VS2. Go ahead and plug in numbers here. It's equal to 4. And same thing, so subtract 4 by 2.622, which will give you 1.378 volts. Okay. Now that we did that, we can go ahead and find the currents of I1 and I3 through using Ohm's law. So same principle as how we found I2. We can just say I1 is equal to V1 divided by R1, because we know these values now. So V1 is 9.378 volts divided by 56 ohms, which gives you a value of 0.167 amps. We can find I3, same thing, so V3 over R3. We found V3 to be 1.378, and our given resistance value was 27 ohms, which gives you a current of 0.051 amps. And let me go ahead and highlight those. And final thing, we can also find the currents across the voltage sources through our KCL equations also, because we can see here that it's pretty simple actually. So our current across voltage source 1 is actually just equal to the current across resistor 1. And also for our current across the second voltage source here, same thing, it's just equal to current 3. So we can say here IS1 is equal to I1, which is equal to 0.167 amps. And IS2 is equal to I3, which is equal to 0.051 amps. Now we just found each voltage drop and current for the circuit using KCL and KVL. I hope this was able to help you be able to learn in this subject, and just keep practicing and you'll get there. And hope you have a good day, and I'll see you in the next one.